So let's go ahead and talk about a slightly different concept, but still related. Let's talk about actually executing queries that we're given. Right, so this is the other piece. So now we know how to write the query based on what we want to find. But let's talk about if we're given a query, right, we're going to play the part of the computer here a little bit and figure out what would we actually be selecting given a set of data sets in a query. So we're going to go through 3 examples that are all going to be based on this data set here. So just a little bit of background. What we have is we have 3 lakes, which are the sort of blue odd shapes here. We have a series of land parcels that are the green sort of rectangular squares. And then we have a series of weather stations that are the gray points. So we have 1 point data set stations, and then we have 2 polygon data sets that are parcels. One thing I do want to clarify, just because it might matter, right, is that in the cases where the parcels go underneath the lake, we are implying that they share this boundary in common, right? That the edge of the parcel is the edge of the lake. That's just not really a great way for me to show that otherwise. But just keep in mind that this line would be coincident between both. All right. So let's go ahead and go through a couple of examples here. So the first example is going to be talking about parcels that share lines with lakes. Right. So the first thing you need to do is figure out what data set are we selecting from. Right. Well, if we remember the sort of structure of a query, the first piece is always going to be the input features. So we know that what we're going to be returning out is parcels. So we're going to be looking for parcels to select. Right. The relationship is the second piece. So that's shares line with. So in this case, right, the comparison that we're making is whether or not the parcels have a line segment or one or more line segments in common with our selecting features, which are the lakes. Okay. So let's go ahead and apply that logic to this data set and talk about what we're going to grab. So I'm going to use red just because it's the color of the input features to kind of show what we're going to be grabbing here. Right, and so we're looking at parcels and comparing them to lakes. So let's go ahead. I've numbered everything here. Let's go ahead and go in order. Right, so parcel 1, right, compared, right, it has this line here. So we know that we would actually grab parcel 1. Right, this would be returned. Right, parcel 2, right, shares this line segment here, right, in common with lake 1, so we would also return parcel 2. Right. Parcel 3, there's no lake nearby it, so it can't share a line, so parcel 3 would not be returned. Right, we jump down here. Parcel 4, even though it's nearby, right, doesn't share any geometry, so we would not return parcel 4. Right, parcel 5 shares this little geometry bit right here with lake 3, so we actually would return parcel 5. Right, and then finally parcel 6, right, again, close but not quite, so we would not return parcel 6. Right, so if we were to apply parcels share line with lakes, we would end up returning parcels 1, 2, and 5. Hopefully that makes sense. Again, we're playing the part of the computer here, and we're evaluating this expression for each of the input features relative to the selecting features. So let's go ahead and look at another example here, an example of parcels containing stations. Right, so just like last time, let's go ahead and break this down. Right, the first word in the query is always going to be what we're selecting from. So again, just like with the last example, right, we're going to be selecting from parcels. So we're going to be selecting from the green squares here. How are we doing the selection? Well, we're doing it based on contains. Right? If you remember, what contains does is contains is saying, right, does the input feature, have any selecting features inside? Right. Now, what are we doing the comparison against? Right. Well, we're doing the comparison against stations. Right. So just to remind everybody, right, stations here is going to be the black points or the gray points here. So just like with example 1, we're going to go parcel by parcel and we're going to make these comparisons. Right. So parcel 1, right, again, we're assuming that it shares that water boundary. There's actually no station in here, so we would not keep parcel 1. Right, parcel 2, right, it actually does, right, it has station 4 inside of it, so we would return parcel 2. Right, parcel 3, right, it has station 3 inside of it, so we would return parcel 3. Right, parcel 4, right, it does have a station, right, station 8 inside of it, so we would return parcel 4. Right, parcel 5, the idea here is that it shares this boundary with the lake, so even though this might be in the lake, it is not inside of the parcel. So we would actually not return parcel 5. But then parcel 6, right, it has station 7 in it, so we actually would return parcel 6. Right, so given the spatial query parcels contain stations, right, we would go ahead and we would grab parcels 2, 3, 4, and 6 because they all have a station inside of them. Hopefully that makes sense. So let's go ahead and do one more example. Let's look at stations within lakes. Right? So let's break it down just like we've done before. Right? What are we selecting from? Well, we're going to be selecting from stations, which means we're going to make this comparison on the stations. So what we're going to be returning is going to be stations. We're going to make the comparison of within. Right? And again, within is sort of the opposite of contains. So what within is going to do is it's going to say, is the input feature right inside of the selecting feature? Right. And what are we making the comparison against? Well, we're making the comparison against lakes. Right. So let's go ahead and run through this expression here. And again, right, we're looking at all of the stations in this case. So is station 1 inside of a lake? Well, yes, it's inside of lake 1. So we would return station 1. Right, station 2, right, is not inside of a lake. So therefore we wouldn't return that. Station 3 is inside of a parcel, right, but we don't care about parcels, we only care about lakes. So we actually would not return station 3. For the same reason, right, we would not return station 4. Station 5, right, again, is not inside of anything, so we're not going to return that. Same thing with 6. All right, 7, again, it's inside of a parcel, but not a lake, so we don't return that. All right, 8, same thing. All right, but 9 is actually inside of lake 3, so we actually would return 9. All right, so given stations within lakes, we actually would return station 1 and station 9. So hopefully that example made sense. Let's look at one more example. lakes intersect parcels. So just like before, right, the thing that we're selecting from is lakes. The relationship that we're doing is intersect, right, which again, intersect means, right, any part of the input feature. Right, that touches, right, a selecting feature. And then what are we selecting against? Well, we're selecting against, right, parcels. So in this case, right, we're basing it on lakes. So we're going to look at each of the 3 lakes in turn. Right, so does lake 1 intersect parcels? Well, yeah, it intersects parcel 1. Right, it also intersects parcel 2. So we would return lake 1. What about lake 2? Well, lake 2, unfortunately, right, is not touching parcel 6. So it's actually not intersecting any of the parcels. So we actually would not return lake 2. Right, lake 3, right, as we said before, right, it shares a boundary here with parcel 5. So we actually would go ahead and return lake 3. Right. So in this case, right, lakes intersect parcels, right, we would return lake 1 and we would return lake 3. Okay, so hopefully all those examples made sense because it's time for you to try this yourself with a couple of review questions. So just to give a little bit of an overview, right, in this case, this graphic over here is going to be the data sets that we're working with. We have these sort of gray boxes here. These are going to be land parcels, right? We have the dashed lines. These are going to be driveways and roadways. And then we have the black dots that represent mailboxes. So the questions are going to be dealing with mailbox, road segment, and parcel. So hopefully that makes sense. All right, so let's go ahead and dive into the first question. The first question is mailboxes that intersect parcels. So go ahead, pause the video, try to work out which mailboxes are going to be returned. Okay, so hopefully you paused the video and took a minute to work through it. But basically what we're going to be grabbing here is mailbox 4, right? Box 3, box 5, and box 6. Right, because those are the 3 that are actually intersecting parcels. All right, let's look at another question here. What about roads that are within parcels? So go ahead, pause the video, take a second to give that a shot. Okay, so again, right, within, actually I'm going to underline this, right, it means that whatever road we pick has to be completely inside of parcels. So that would actually eliminate road 3, right, because road 3 goes over the boundary. It is not completely within. So we would actually return road 5. Well, actually, hold on. Let's start at the top, right? We would return road 2. Right, we would return road 5. Right, we would return road 6. And we would return, right, road 8. So hopefully that makes sense. Again, within disqualifies this one because it goes over the boundary. All right, so hopefully that makes sense, this idea of how we actually execute queries. And as always, if you have any questions, please reach out.